Professor Dr. Ismail and my classmates, we are Group 2 presenting our Free Space Management Algorithm Visualizer, an interactive tool demonstrate how operating system manage space through various allocation algorithm. Our team includes, and my name is MOHANASUNDRAM, NURIYLIA, SYAHIRAH and SYAHIRAH. So let's we go for the project review. Our mission is bridge the gap between theoretical OS concept and practical storage management. Our visualizer provides 4 keys: visual learning through dynamic animation, real-world scenario including cloud storage and database, performance metering in qualities analysis, and interactive controls on hand-on experience. Now, let's go for the problem statement. Current educational approaches are static. Textbook can't show dynamic allocation between behavior. Students struggle to understand fragmentation augmentation, can't compare algorithm performance, and lack practical for experimentation. This gap between theoretical knowledge and practical understanding of management trade-off. So that's why we bring our solution. So let me see what is the solution. Our integrative visualization provides a real-time algorithm simulator with comparative analysis. User watch allocation process in real time, monitor fragmentation, bydup, compare algorithm performance directly, and get quantitative metrics showing success rates and storage efficiency. We demonstrate 4 fundamentals, that is first fit, best fit, worst fit, and next fit. We are simulate 4 major applications: cloud storage, database management, personal computing, and enterprise system. Now let's see how our system performance. Our system provides comparative analysis through 4 metrics: fragmentation analysis with real-time monitoring, allocation efficiency measuring success rates and speed, storing utilization calculating efficient space usage, and defragment impact showing before and after performance improvements. Now for the system features, it gives the interactive control, and we got some advanced analysis also. We are okay for the next part, I pass to my group member.
Hi, so basically I will continue with the related works. So free space management is an important topic in operating system and it mainly involves 2 big parts. First, the way the operating system keeps track of free space, for example, using bitmaps, linked lists, or grouping and counting methods. Second, it includes allocation strategies, which is where our project focuses. These are methods like first fit, best fit, worst fit, and next fit that decide where to place new files in the available space. Most of the information can be found in the internet. However, all these sources mainly use static diagrams and examples to explain concepts. They don't really show how fragmentation works or how allocation changes over time. That's why we choose to focus on building a visualizer to demonstrate these allocation strategies. So our project will help to show a more practical and clear way to understand how this algorithm really works. So basically, we started by doing a simple requirement analysis where we identified the main goals for our project. We wanted to show how each allocation strategy behaves, how fragmentation happens, and use simple diagrams instead of a full software interface to make it easier to understand. Then in our system design, we broke down the concept into 3 parts. The first is input. This is where the user decides the file sizes and picks the allocation strategy. The second is the allocation logic, which applies the selected strategy to place the file into a suitable block. And lastly, we have visualization, which shows block diagrams indicating which parts are occupied and which are still free. This will also highlight the fragmentation. Instead of building a complicated user interface, we prepared a diagram and bar illustration for each allocation strategy. This will help us clearly show how files get allocated differently under each method. And finally, we did testing and observation by simulating different sequences of file sizes and manually updating our diagrams. This allowed us to compare how first fit, best fit, worst fit, and next fit perform with the same set of file requests.
Hi. Moving on to design and implementation, which is actually concept by a block diagram, which visually depict how files are allocated in memory based on the chosen method. Each allocation technique uses a specific rule to place where the plays are in the new file. So initial memory setup. Assume that 100 unit memory block with the following three blocks, which is block A has 10 units, it indicates free. Block B has 20 units allocated. Block C 15 units called as free. Block D has 30 units which is allocated, and block E has 25 units which is free. So for example file request, we simulate the allocation of these file sizes. File X has 12 units, file Y has 8 units, file Z has 10 units. So we'll go to the first, which is the first fit. First fit X is assigned to block C, the first free block that is large enough. File Y moves to block E. File Z takes up the remaining space in block E. Next, for the best fit, file X corresponds to block C, which is 15 units, closest fit, and file Y travels to block A, which is 10 units, closest to 8, and file Z will be assigned to the block E. The remaining of 25 units are the next best option. And moving on to the worst fit, file X is assigned to block E, biggest sphere block. File Y moves to block E following X. File Z moves to block C. And for the next is actually next fit. Next fit, begin searching from the last allotted block. File Z is insert in block C, followed by the file Y in block E, and file Z can be insert in block E or wrapped around. So the next one is actually the based on the result discussion, which is all the strategy for first, best fit, worst fit, and next fit. Allocation success is high and fragmentation is moderate. Simple and very fast can lead to fragmentation in early blocks. The next is for the best fit. Medium and fragmentation is actually high, tends to leave small unusable fragments. Is a very medium to be not that much of faster enough. Worst fit is high, but it's kind of low, may delay some fragmentation under underlies memory. Sending the file, it might be a bit delay for that. And for the next fit is medium, moderate, balanced, but still it may miss some early fits actually. So these are the results and discussion based on like the simulator allow us to see evaluate how different allocation algorithms respond to identical file allocation requests. So that's all from me. Thank you.
Hi, my name is NURIYLIA Binti ZULKIFLY. So I'm going to explain, or I'm going to present a bit and present a pointless about important things about future works or conclusion for free management system. So first of all, I'm going to explain about future works first. So maybe this one is a few point about future works in or for free management system. First of all, I'm going to explain about support for real-time simulation. So for real-time simulation, it's implement dynamic allocation or deallocation to simulate real-time memory operations. So the second one or next of the of our point is advanced allocation strategies. So for advanced allocation strategies, it include algorithm with system or allocation for more comprehensive learning for student or who that want to learn about it. Okay, so next is performance. So for performance integration, we basically it's display statistics about or such as fragmentation rate, memory utilization, and also time complexity. Okay, for next is input functionality. So for input functionality, basically we allow, or this system will allow user to input custom test cases or adjust parameters. So I can give example. So the example for test cases or adjust parameters is maybe can adjust or test cases in memory size or block size. Okay, so next is for learning features. For learning features also, it's enable step-by-step execution, also algorithm comparison, and also it can explain to enhance understand for student and also who that likes or who wants to learn about it. Okay, so next is about web-based or mobile version. For web-based and mobile version, basically it's develop a responsive version accessible via web and also mobile device. Okay, so the next one is for saving and sharing. For saving and sharing also, this system will allow saving to export of result for documentation and also collaborating or collaborative learning. Okay, and also next is visualization enhancement. For visualization enhancement, this system or the future works for this system can improve UI with better animation, better labeling, and also the color coding for easier tracking. Yes, for easier tracking for student to learn more and to more understand about it. Okay, so for the last one, the last point from me is file system simulation. So file system simulation, basically it's extend to tool, this is the tool to simulate file system level space management. Okay, and also for learning platform. Okay, for learning platform, that integration, or we call this integration with learning platform, this system can link with maybe Google Classroom, Moodle, or other website for academic use also. Okay, so next I will explain a bit about the conclusion for free space management. So the first point is for the conclusion is component of memory management. So for component memory management, the free space management plays a critical role in optimizing the memory or in operating system. So next is the improve of system efficiency. So improve for system efficiency is all about allocation or efficient allocation that have strategies to reduce fragmentation and enhance to reduce overall system performance. Okay, so next is the strategies for different needs. Okay, so the different strategies for different needs, usually we use a first fit. We have the system, or the system have first fit best fit and also worst fit. So this 3 fit is obviously a trade-off between speed and memory usage. So these three have a different these three have different speed and also memory usage. So next is visualization understanding. So for visualization understanding, these tools can help learns and also develop understanding about the behavior or the differentiate of algorithm more clearly for student. Basically for student, this can more clearly make them understand the memory of the file system. So next is the improvement. So this is the next or the last point that I can give for improvement. So this one is ongoing. It's called ongoing need for improvement. So the system grow more in blocks. This system basically is grow more complex. Okay, more complex but have a more free space management, and also we have a technique. Okay, we have a technique that can involve or must involve to address a new performance of a scalability challenge. So that means this improvement we have and also the student must have a technique to understand the system and also to have a new performance on, and also the challenge to make it more improved, and also this will be the best system ever for student to learn. Okay, so this is all from me, and also I did that my friend also already explained about their parts. Okay, so I'm going to say thank you to our lecturer and also to our team for their best serving in report, and also serving in this video to make our lecturer and also our team and also student that want to learn about free space management. So this is all from me and my friend. So I'm going to say thank you to our lecturer and who is watching our video. So I hope this video can help you guys to understand and make you guys more understand and also more interesting to learn about free space management. So thank you from us.